3, that is sustainability. So I had made some slides, but I'll just link with the talk which has just happened. Sir has given talked about that agriculture. So see, that was the curiosity I had, that the growth of population is increasing, but still it is going to decrease. After some time, it is going to decrease, and the food production has increased, and it is all because of that chemical engineer Haber Bosch process. Because of his uh, innovation, we this ammonia has been produced. Otherwise, we would not have been sustained. That this much amount of life would not have been sustained, because the cycle of nitrogen reproduction in the soil is very slow. So he had invented that process to reduce that nitrogen which is there in the environment and put back in form of ammonia to the soil, so that that much amount of food can be produced. The plant can grow, but to grow a food you need nitrogen. So to sustain life, chemical engineer has that part, food thing. But now, since the food has already reached to that level that more or less everyone is getting food, that food is not a very big issue. If a person works hard, he can get some amount of money with the in which the like the roti kapda makan, the roti part is not that big. The kapda and makan is the more important thing. Obviously, this has happened in not only, well, it is a difficulty in Africa, but again in Africa also that issue will be sorted out pretty soon in 10 to 15 years. We are talking about sustainability. So what is the issue with the issue is the supply chain gap, the management, the demand supply gap. So how can we manage that supply chain? Like, yeah, the banana can get uh, खराब हो जाएगा, कुछ दिन तक रखने पे खराब हो जाएगा. So you can do all the chemical engineering. One way of looking at that, you can take that gas out and avoid that banana to get ripened. The other way of looking at it is that you manage that consumption of banana in a given locality. You study that data and then get the data of how what is the actual demand of banana and in what time that demand is actually decreasing. So you can manage the demand supply gap by from data. And now we are generating data in enormous way as we are interacting with this new technology, computers. So we are producing all that data. We can easily give that data that okay, this much amount of demand is there for food or for anything. So artificial intelligence can bridge that gap. So rather than increasing the shelf life of a banana, you can just grow the banana at that time or grow another the same type of some tasty type of fruit for that environment to that extent, so that it can just catch the demand, that you don't need to increase the shelf life just by artificial intelligence, but just by using the data in more smart way. So this is something I had just uh, typed that goat. So this is what I was trying to do. All those slides, I'm going to skip all these things. So this all just trying to this I had already done. Okay. So now I think you all are okay. Like you agree that artificial intelligence is important for sustainability. Okay. Everyone is okay that artificial intelligence, if we use the data in a better manner, we can create a sustainable environment. Okay. So now coming, now let's be aware of what is artificial intelligence, and this will be a very introductory information, very base information. I'm not going to go deep. Just a brief overview. What is artificial intelligence? Because this is the talk of the town. Artificial intelligence, chat GPT, everything is being done by artificial intelligence. And what is it? To understand an overview of that is what I want to. So artificial intelligence is that anything which can act, can sense, reason, and adapt. Like my spectacle, this is a photochromatic layer. If I go in sun, it can sense, it can adapt, and then that is the artificial intelligence. It has art intelligence with artificial. So that artificial intelligence is a very big, okay, which anything which can sense and can adapt. So that is artificial. Now the main part is the machine learning. How is it machine learning which is inside that artificial intelligence? How is it different than artificial intelligence, the machine learning? Machine learning, as the name suggests, learning. As the name suggests, learning means something is already, that information is already there. But see, this has been trained in a particular manner. It is not going to improve. The more exposure I'll get it to that, how much exposure I get it to the sun, how much, like, it cannot change its nature. It has already been trained. Like we call to a call center. Press this if you want to do that. Press that if you want to do that. It can sense. It can go to lead to a level. But the more number of people will are using it, it is not going to improve that algorithm. The data, if you feed that data, it is not going to improve it. The machine learning is something which can learn. A machine which can learn means if we interact with it, if we get more data to that, it is going to improve. So that is machine learning. I think everyone understood now what is machine learning, how is it different than from artificial intelligence. So these are the things I wanted to give it to you. The basics. That what is machine learning, how is it different from artificial. Then there is another thing, that is deep learning. Machine learning is still at computer programs, algorithms. The normal algorithm which has already been made, okay, that can improve by itself, but it has been coded in a same pattern. But the idea was the intelligence. The idea was the intelligence. We have a luxury of having billions of neurons in our mind, which can be trained, which can be, we can train those billions of neurons and improve our learning of that neuron. So the idea was from the very starting to copy human intelligence. So the way human intelligence works, if we follow that path, that way of algorithm, that algorithm is deep learning. That uses the concept of different layers of neural network. Okay, we'll again come back to this. Now, I want to differentiate first a mathematical modeling and artificial intelligence. What is the difference? Because we go through that this mathematical modeling we had, all the engineering is about mathematical modeling. How is it this mathematical modeling is different than artificial intelligence? So what do we do in a mathematical modeling? There's a system. There's a system. There are inputs: pressure, temperature, concentration, and number of things. Okay. Then there is an output, yield. Okay, conversion, and in other engineering things, some other output. There's a system where some input operating conditions are there, and some output is desired output is coming out. We want to predict this output in terms of this x. That is what we want. And for that, how do we get that prediction? By applying physics of that system. We understand the physics, how this system works. Then we apply that physics, and that is function f. I should have uploaded that PDF amount. Cutting some part. Okay, anyway. So I think I should move to PDF, or is it okay? Okay. If anything will happen, then I'll I'll change that. Anyway, so see, this is a input x, output y. We want to get it, predict the y, and for that, इधर भी जाओ उधर जा रहा है. This is the easier way. I think you can. Yeah. So we apply that like conservation in chemical engineering. You're all. What do we do? We apply conservation laws. This is the assumption. We can assume that the heat transfer is very good. The energy balance is not required because temperature is going to be constant. So energy balance is all gone. In one reactor, like let's say only the momentum balance and this is required. Only the flow is happening in this direction. All the velocities are gone. So all the differential equation which has been formed by applying the conservation equation has reduced to a simple function. We integrate it and then we get some function for that specific scenario. We apply the assumptions, then we apply the boundary condition, we integrate, we get the function. That is how the chemical engineering, all the different functions are there. What is there in the function? One is the function f itself, how it is formed, and then there are some parameters which are inherent to that system. And then the P is of the system. The P is of the system. We try to fit those P values from data. So we first train that the model because that model is not always 100% first principle. There is always some empiricism is there. That empiricism is there in terms of model. Like we first try to fit the let's say ideal plug flow reactor. Then there is a dispersion coefficient. That dispersion coefficient we have to fit it with the data. So we always require some parameters which we fit it, but the main trick part is that the parameters are of the system. Okay, the function is of the system. How is it in artificial intelligence? There is a x, y, no physics is needed. We predict phi in terms of an algorithm. The f is being replaced by algorithm, and there are weights in that algorithm. There are weights in that algorithm. These weights are of algorithm and not of the system. These weights are, these parameters are of the algorithm, not of the system. And there is an algorithm, not a function. So you don't need physics, but the number of weights in algorithm are tremendously high. As I was telling about that when we move from the machine learning to deep learning, the number of parameters which in the machine learning is in thousands, that's a maximum number, trillion in deep learning. Then the amount of data which is needed to train that algorithm will also be enormous. But the issue is that in an operating plant, let's say you have to, in a working life, the data is continuously coming. We just have to utilize that. In a plant, if you look in a chemical engineering, you can take that example of that data of food also, but let's take the example of a plant, chemical plant. The temperature, pressure, and all those things at different locations are continuously being generated. There's a long history. It's a sensor, and that time is also like how much time does it take that measure that variable. Okay, you can create a number of data, and now you can utilize that enormous which is being generated in a plant and being wasted. All that information is being wasted. We can utilize it to train an algorithm. That algorithm will be able to, and the main objective of both the mathematical model and the machine learning or the artificial intelligence is to get the accurate answer, not the exact. That is a very big catch. That even in mathematical modeling also, we don't need. So if we get too much data, we can get the same level of accuracy with much less knowledge about that function. So That was the next slide. That, see, we have one system of heat transfer, the other system of mass transfer, third system of something else. Okay, so we have to apply for every system. There will be some applications also. The heat exchanger can also be modeled for fouling. That can be modeled for getting the what is the heat requirement, the energy consumption. All the things can be different applications can be used to the same system. So different functions will be there, different parameters will be there for different applications. There will be so many number of functions, so many number of parameters, and even then there will always be a level of accuracy will be depending on how accurate we are modeling. We never model we never model actual system. We model first an ideal system and then try to fit that non-ideality. So it's always about accuracy. We never model a real system. We always model a ideal system. Anyway, so how many numbers of functions will be there? How many number of parameters will be there at the end of all? Anyway, getting the accurate answer, not the exact answer. We have to get the accurate answer. So why get in different applications, different systems, any system, be it any system, it doesn't matter the physics. It only matters the application. For different applications, there will be different algorithms. केमिकल इंजीनियरिंग की प्रॉब्लम हो, मैकेनिकल इंजीनियरिंग की प्रॉब्लम हो, किसी भी इंजीनियरिंग की प्रॉब्लम हो, अगर इवन मैथमेटिकल मॉडलिंग करनी होती है तो यू हैव टू यूज मैटलैब. मैटलैब में क्या होता है? एल्गोरिथम होता है. एल्गोरिथम में क्या? बी सॉल्वर, बी, ऑल दो सॉल्वर्स, नॉन लीनियर सॉल्वर्स, एप्लीकेशंस होते हैं. ये थोड़ी होता है कि किस सिस्टम का है, किस सिस्टम का नहीं है. तो सिमिलर दैट इज फॉर मैथमेटिकल मॉडल यूज्ड फॉर solving mathematical problems. Similarly, for doing predicting something, artificial intelligence, that as an algorithm, then for different applications, we just have to use different. There will be different algorithms for sure, but that application part, the system part will be gone. The complicacy will be much less. Got it? So that is something is a brief overview of artificial intelligence and the deep learning which I was talking about, the neural networks. Here, the number of parameters are huge. Okay. Anyway, one more thing I thought that I thought this slide. Yeah, level of accuracy. Yeah. So I think that is done. Now coming to a brief overview of what are the different types of machine learning. Is it okay? Should I continue? No. Okay. So there are three types of machine learning. Just an overview. I'm not going to go into it. जहां तक आपको अच्छा लगेगा वहां तक पढ़ा देंगे. ठीक है? So machine learning में तीन तरह के machine learning होते हैं. There are three types of machine learning. One is supervised, one is unsupervised. The last one is reinforced. There are mixed also. Okay. So supervised is in a very vague language. When x and y both are present. When x and y, like y, there is a system, x is there, y is there, both x and y is there, then that is known as supervised learning. If there is no y, and then also you have to predict something just on x, that is unsupervised learning. We'll discuss about that a little bit. And when neither x is there nor y is there, and still you have to do some prediction. Use algorithm, that is reinforced learning. That is the agent. So let's go one by one. So that is something is I think yeah, definition that supervised learning, there is a supervisor who trains. So there is a labeled thing. Supervisor is not the actual explanation. It is that a supervisor can tell that this output with this part. So there is an algorithm, you need data to get it trained. That data is going to have both x and y. Then you train that algorithm with that type of data with x and y. So every data, every observation of this operating condition, this is the output. It is labeled like an example that from the very starting, you had been shown that this is apple by with a photo with some features, color, and then a photo and then a label. This is apple. This is a guava. Photos, features, and then label. Y also is there. And n number of data has been given it to you, your neurons. And that neurons are getting trained by labeled data. That is supervised training. These are features, and when these features will be there, this will be the output. And then slowly your neurons get trained. The weights and biases, the spark, the amount of spark, the activation energy which is required in your neurons, they get trained. And in algorithm, there are some parameters which get trained by those labeled data. These are the conditions. So in different applications, as I said, these types of applications are there. First is in predicting something. You have algorithm, you have been trained by this type of data which have X values and Y value. Okay, from your side, sorry, X value and Y value. This type of data is there. You have been, that data has been given. Now this algorithm has been trained. Now, if you give any X, it will give this amount of Y. This is called prediction. Now that prediction can be two types. Prediction can be two types. One can be what is the value of Y, what is the class of Y. Like in this scenario, whether the heat exchanger has been fouled and it is going to stop working. That is a category. Y is a category, but it's working, it's not working. So predicting a category is classification. Predicting a value is regression. That applications I was talking about for different application, different types, which system is there. If you learn this machine learning, it will be useful for chemical, it will be useful for everyone. It doesn't matter. Everyone has it in this new world. Okay. So supervised learning, the application part of supervised learning is what is the application? That is what you have to be much. What is the algorithm might not be important for you. The code might not be important for you because the code is already written in the NumPy library. You just have to use some library. If you have to be aware that which algorithm you have to use in which scenario, that is the level of learning you need as a chemical engineer. Okay, so in supervised learning, if you have to predict something or you have to classify something in given scenario, then you use the algorithms of supervised. Got it? Now, what happens when Y is not there, only X is there? Then what we have to do? करना क्या है? Y है ही नहीं, तो ट्रेन क्या कर रहे हैं? ट्रेन कर रहे हैं, जैसे आप लोगों को आप लोगों से इंटरेक्ट करते हो तो लोगों को अलग अलग कैटेगरी में बांट देते हो. ये इस टाइप का है, वो उस टाइप का है, just based on their features. Then you are being trained with different people. You are not trained कि भाई ये ऐसा है और तब आप ट्रेन होते हो. आप उनके फीचर्स को देखते हो और आप अपने आप से कैटेगराइज कर देते हो कि ये इस तरह के लोग हैं, ये उस तरह के लोग. While getting trained, there is no output. When you are trained that this person is of this type, that this type has not been labeled previously, you are getting trained, you are categorizing based on features. So that's a different application. Classification and categorization, classification and categorization, or that is clustering, is different. Clustering is done cluster, एक cluster में दूसरे cluster में तीसरे cluster. Use जैसे एसोसिएट करना किसी चीज से, थक गए हो, आधे लोग थक गए, आधे लोग. So I think everyone is leaving, so I'll stop here. ठीक है, और थोड़ा बहुत reinforced learning हल्का सा बताते हैं. मेरे पास पूरा एग्जांपल भी था, रियल लाइफ एग्जांपल केमिकल इंजीनियरिंग का. थक गए हो. But see, this artificial intelligence is something is you can stop it recording and I'll continue this. just a normal interaction. ठीक है कि आर्टिफिशियल इंटेलिजेंस